Or if I really am mean, I'll look at my pretend watch and say, you're late. Thank you, Dr. Bixby, for inviting me to give this session. This is our agenda in essence. Really, introductions will be the first part, but the meat of the thing of my talk will be divided into 3 sections. Talk about a little bit about the theory of learning, talk a little bit about my experiences and my understanding, and a little bit of research on lecturing and how that relates back to the theory of learning, and then I'll wrap up with assessment in itself. So I think it's really important for people to know who is it that they're listening to, who they're speaking about, and I also like to get a little bit of information about you as well. So my background is this. I started off as an undergrad 100 and something years ago, I think, at San Jose State University. I got a degree in biology, and my goal was to become a high school biology teacher. I did that. I took a couple extra classes, and then was able to get a second license and became a chemistry teacher. And I really love teaching chemistry. I love studying biology, but I love teaching chemistry. Probably because I could make things turn colors and I could make things explode, and that just attracted me more greatly. So while I was teaching, I got this wild idea that I wanted to teach teachers how to teach. And so I applied to grad school and went to Purdue and got a master's degree in chemistry. Then I went and got my PhD in chemical education. Then after graduation, I spent about 14 years at Cleveland State University. Good morning, how are you? See how that worked, huh? All right, anyway, working at Cleveland State University in their Department of Teacher Education, and then 2017, I came to North Carolina A&T. I've been here now, finishing up my second year at A&T. So career-wise, a little bit of my background. I got a background in biology, did some chemistry. Oh, it's a touch screen.
It is a touch screen.
No.
Try the other way.
No.
Yeah, I forgot
I'm
to
gonna go
warn
one
you.
way. They got the answers already. All right. So I did some biology, did some chemistry, science education, and now I think of myself mostly as elementary ed. My Department of Educator prep has really only one undergraduate program. That's to prepare K-6 teachers, and that's what I'm doing now. So this is really a much more intimate group than I envisioned. So I think this is what I understood. I'm going to be lecturing to STEM people with a strong background in STEM, and you have a desire to pursue careers as tenure-track faculty. Yes, this is true. So there's 5. Who are you? You can even just say, hi, my name is, and I'm studying this, and this is my background. And you're just like trying to avoid my eye contact, so I'm going to pick on you first. Do you mind going first? You can say no. It's okay. So who are you?
I'm Charette Godfrey. I'm a 4th year PhD student, and I'm in the Department of Applied Science and Technology.
Okay.
Hanan Ashahir. I'm a computer science PhD student.
And I guess we have a Department of Computer Science in the College of Engineering.
Yes.
Okay. If you want to catch your breath, I'll move along and come back to you. Is that okay? All right.
Good morning, Dr. Ferguson.
Good morning.
Ron Wilkins, Dr. Ron Wilkins. I got my PhD from Leadership Studies 2018. I'm currently teaching in the Department of Applied Engineering and Technology in the College of Science and Technology. And hopefully might look at that PhD program.
Very good, very good. So, well, go ahead.
Sure.
You're still in line.
Yeah, I'm Dr. Shea Bixby. I work with the Graduate College. Many of you know me from my work with the thesis and dissertation submission process. My background is actually in humanities. My both undergraduate and graduate degrees are in English. And I came to the Graduate College because they were looking for assistance with writing generally, just to give you all a little bit more background on myself. And now I'm really enjoying working with students across a range of disciplines, across STEM disciplines primarily here, as well as some social science adjacent disciplines.
You just never know where
Precisely.
you're going to go next.
Yep.
Matt?
Yeah, my name is Polari Oluwafunke. I'm in the Leadership Studies program, PhD, my 3rd year.
All right. So a couple from my college. All right.
Yeah,
Yes,
true.
sir.
From electrical engineering, concentrations, computer engineering. My focus of research is pervasive healthcare.
Oh, wow. Wow. And you may get your name. Okay?
Michael Chestnut.
Michael. Okay.
Yeah, the second.
I'm Kehinde Odubela, second year PhD student in Industrial and Systems Engineering.
Very good. Well, thank you all. So I know you're busy and taking time out to come and listen to me. So one of the goals I think is really important is work, right? I hope this is a worthwhile hour for you. And if it isn't, don't tell me because I'll cry. But if it is, you can tell me because I'll laugh as well. All right. So the first question I really want to ask you is, everyone has a thought on how others learn. Some of you are already lecturing, it sounds like. Some of you are getting ready. This whole program is designed so if you do go into the professorate, you're going to be expected to research, you're going to be expected to do service, and you're going to be expected to teach. So I'd like to hear what your theories are. And if this were my classroom, I'd have a board right here. I would be writing right here some of your ideas, but it's a little more formal than that. So, but I wouldn't mind, how do people learn? What are your theories on how people learn?
In my case, I prefer something visual.
Visual, okay.
And after visualize this thing, I read what I see. So I think some people like to listen.
Mm-hmm.
So when we mix between listening and visualization and reading, I think it's the best combination to
Okay. And make sure the two. All right. Other people? Thank you.
Yeah, so I think maybe most of the times your classes are going to be divided between those that prefer to learn using like visual cues and you give them examples of, oh, this is what it looks like. And there are some people that really want to have a feel of what you're talking about. There are some people that just want to listen to you talk. They really won't even write anything in class. So I think all of those are like different approaches of ideas which people learn. Then I also think that it's very possible for anyone to learn anything. It just depends on how you put it towards the person. It just depends on the methodology and the approach that you use to teach. So if you come across as making it sound very difficult, like even though it took you sometimes for you to learn it, you who are the teacher, but the way you present it to the students and how you talk about the concepts will either develop their interest in it or make them want to learn.
All right. So that, and I don't want to stop the conversation, but that's going to be an important point is the how. Other ideas? There's only two. We're going to at least get a third one.
As for me, it's not only that, but the piggyback back how well you can relate to someone on a personal level.
Okay. Like a personal connection?
Yeah, personal connection. Like for instance, when I coach, sometimes you don't know the level of education of the student or what they have going on at home or anything else. So you try to connect with them and show them things from your point of view that may help them out.
Good. All right, so we have visual, but a mixture of listening, visual, mixture of listening, and also a little bit of how, and making some personal connections. Anyone else? When I see the hamster in your brain is spinning, but you're not going to say anything, huh? Okay. All right, so I do want to do a true confession here. So when Dr. Bigsby invited me to make this presentation, he gave me this topic, and I thought, yeah, I could just list things you can do as a lecturer. And I hope you'll forgive me, I'm not going to do that directly. What I thought instead would be more useful is getting back to the how. And so my agenda, behind the agenda, is not an effective, anyways, it's not just a list of do's and don'ts. Instead, I'm going to give you more of a theoretical perspective. And I hope that, again, is worthwhile to you. So I'm going to start with this. My background is chemistry. I have PhDs in chemical education, and this is my prop. This is a gallon of gasoline. My true confession, it's not really gasoline, so if you need to smoke, it's okay. It's not going to catch on fire. It's water that's been dyed, but it should look like a gallon of gasoline. And does it?
Yeah.
Yeah, pretty convincing. I think so too. And maybe you have to teach this idea of, well, when you combust gasoline in your car, did anyone not drive here today? One person. So everyone else drove a car to get here. Anyone drive a Tesla or electric car? So everyone else drove an internal combustion engine, right? All right. So you burned at least a gallon of gasoline to get here. Yes?
Yes.
Okay, we'll agree on some rules. This is yes. This is no. All right. So you burned a gallon of gas, and perhaps you need to teach how much CO2. So I'm sorry. Let me go back. The product of combustion, as you probably know, forgive me for time, right? You take some sort of combustible plus an excess of oxygen, you're going to make CO2 and water, right? That's combustion. It's also respiration, right? So we're going to combust a gallon of gasoline to drive whatever, 20 miles to the gallon, 30 miles to the gallon, whatever your car gets, and you're going to make CO2. So I'd like you to tell me, if I were your lecturer, how many pounds of CO2 did this 1 gallon of gas produce? Make sense? So how would you teach that?
I would start off by giving some sort of example.
Example, okay. But you would tell them through example?
Well, I mean, for me, the example would start off by having like a formula. So
Okay.
you can have the formula, but then from the formula, you can kind of, for someone that's not into chemistry, you can kind of like tell a story. And so you gave the example of getting to campus, driving the car. So in describing what the different variables mean in the formula, you can kind of tie that into the story.
All right. So we give them a formula and have them work it out, it sounds like. All right? Other ways to do this? All right, so this is a prepared talk. I never know what someone's going to say. So here's what I thought you could do. One, you could just say the answer. The answer is, right? I could solve the problem. Halfway to what you're saying. I could go on the board, scribble. You don't have a lecture where they never look back and they just lecture this way? Yeah?
Used to have that.
Yes, yeah. Probably glad to be out of that class, aren't you? Kind of what you're, so here's the modern version, right? This is long before I was a grad student. Wikipedia now, just look it up, right? Type it in. Actually, I thought if this was a bigger audience, someone in the back would be, on their phone looking up the answer. But you can look up the answer in Wikipedia. Probably give you the right. I know a lot of people are against Wikipedia. Most of the time, it's generally right.
Yeah, it's pretty good.
You can work out and solve the problem. Give the students how they would work out, how your learners would want to work it out. My favorite, you could go into a lab, right? Take a known quantity of this thing, put it in a bomb calorimeter, put enough oxygen in there that there's more than enough, blow the thing up, capture all the CO2 and water, measure one of the two. You only have to measure one, then you can do the math and subtract and figure out the other, and that would give you the answer. Right? So we have lots of ways we could teach this. Do you concur?
Mm-hmm.
My point is, you have to decide which one is the right answer. So I want to lead that into, it would be nice if you had a theory to help you make that decision. And that's where I want to go with this. And by the way, just in case you're curious, it's about 19 pounds, 19 pounds, almost 20 pounds, depending on whose math you believe. So that's 6.3 pounds. Drive a gallon worth of like 20, 25 miles on your car, you just put 20 pounds of CO2 in the air. My Honda holds 12 gallons. 12 times 20 is 240, right? So every time I fill up my tank, I've just put 240 pounds of CO2 in the air. Just so you know, I'm not like preaching. I'm just as guilty as producing greenhouse gases as anyone else. All right, but the real big point is you need a theory. And that's what I wanted to introduce to you, is this notion of pedagogy. Pedagogy is, in colleges of education, this is the one word that's bandied about almost as much as epistemology, right? But pedagogy, if you look at the root of it, it means literally to lead the child, right? Peda is like Pedialyte, right? If you got kids, go see a kid at home, they give them Pedialyte, right? Pediatrics, those kind of things. Unfortunately, pedophiles in our vocabulary now too. It comes from that root. So it's the theory and practice of education. Right? It's the act of giving, of creating an educational experience. It's the act of teaching. If you end up working with adults, they change part of the root and it's andragogy instead. But I don't think theoretically it's going to be a big difference between pedagogy and andragogy for us. And by that, I want you to recognize it. If you have a theory, how do you believe people learn? Is it by giving pictures? Is it by looking at the how? Is it by making personal relationships? That always drives your decision. Whatever's operating back here, it may be implicit, it may be explicit, but whatever's operating in the back of your mind is going to come out on this lecture stage. Even today, what I'm doing, every slide I wrote, every decision I made, the order of the slides was based on some sort of theory, some sort of reasoning to get that. So it's the theory that I would, and you're taking notes like are these notes going to be available for them? I mean, I can just,
We can make the
just
slides
email me, I'll send you
available.
the slides too.
Okay.
There's nothing proprietary on here. Matter of fact, some
Yeah,
of the stuff's ripped off right off of Google. A couple of images, they're free.
Yep.
Yeah, that's what they won't be, the notes. Anything's free, take it.
Yes.
Or borrow it, at least. So philosophical considerations. I think one of the bigger books that you want to read on this, because I know as PhD students you have nothing but free time, is this is a really good place to start. This is written by Bradford, or edited now by Bradford. The second edition, the revised and standard edition came out in 2000, and it is really a compendium of how they understand people. And it's not some foo-foo science educational book written by someone who's all huggy, touchy-feely, saving the whales, tree-hugging kind of thing. And it's from the National Research Council. It's funded by the NIH, the NSF. So it's a pretty heavy-duty, well-established document. So there's three philosophies I'd like you to consider. Three main theories of how people learn. If you go onto Pinterest, you can find a really beautiful diagram that has like 45 different theories on how people learn. I thought for our discussions today, we would just have 3. Are they asking a question, or is that feedback or overlap?
I'm trying to figure that out.
Okay.
I think,
Should we just move on? Or should we talk?
well, I want to,
Are you Domino's or Uber? So I'm going to just keep going if that's okay with you.
That's fine.
All right. So the 3 ideas is there's behaviorism, there's memory, and there's constructivism. So I'd like to just spend one slide on each, give you a sampling, kind of like you're going to a smorgasbord, and you get to taste, put a little each one on your plate, and take a bite. All right. So behaviorism has these ideas endemic to it. I'm not sure where it snaps on that anyway. So it has these big ideas into it, right? First is behaviorism really looks at changes, external changes, and in behavior, of course, right? Hence behaviorism. It looks at how people do things. So if you think that people showing up on time to your class is a big deal, then you might invoke behaviorism to make a change in those students who are showing up late. Right? Class starts at 8 o'clock. 8 o'clock is a class start. I expect people to be on time. If you're not on time, there's going to be a consequence. Deduction of points. Maybe you'll give answers to a quiz, so if they're late, they miss these answers. But whatever, there's some sort of negative consequence. And or there's some sort of reward. I was a high school teacher. I wanted all my students to I had 9th graders. Anyone work with 9th graders like 14 years old?
Yeah.
Mm-hmm.
After 2 years, I believe they should be denied oxygen. That was just my feeling. But apparently it's against the law. So, but I really wanted them all at least once to turn in all the homework. So I could offer them, hey, I'll give you each a candy, right? A nice chocolate Hershey's Kiss if you all turn in your homework. Maybe they did. If I got them all to turn in, you know what happened the next time? They would say things like, well, I want 2 candies. Right? What's in it for me? I really don't like chocolate. I want a caramel. And all of a sudden there's a negotiation taking place. And so behaviorism sort of misplaces what you want to occur. And this is where this notion of reward junkies comes in, right? Well, what's in it for me? I want a bigger reward. Well, what if I do 2 homeworks? Can I get 3 candies? Or, something that eventually goes on. Now, behaviorism does work. You can get students to show up on time. You can invoke it, but it just has some drawbacks. One of the drawbacks is it doesn't get to this how. Right? Behind it, it doesn't get to how. 2 years ago, I got a new puppy. I went to a trainer, and the trainer showed me how to train the puppy. It was all behaviorism. The dog sat and laid down and was quiet, boom, it got a treat. The dog didn't sit down, wasn't quiet, had one of those little choker things, and it didn't like it, and then it stopped doing the behavior and went back to, being a good dog, right? So that's behaviorism. There's rewards and punishments, and it will get the desired results. But it fails to explain how. And I think cognitively, and more interestingly, it doesn't tell us what's going on inside the brain of the learner. We just know everyone started to show up at 8. I got homework turned in. Was it good homework? Was it bad homework? Did they try? Did they just copy? I don't know. I just got homework turned in. So behaviorism has those features to it. Secondly, then, there's memory theories, memorists. And memory theory is also a competing way to think about how to make decisions as you plan. Ideally, there's a couple of places memory is held, right? There's a short-term memory, there's another place where it's being decided if it's going to be kept or not, and then there's this long-term memory. And essentially, long-term memory is a storage system, this retrieval system that's inside the brain, and can you retrieve it? If you're able to retrieve it, then we call that memory. And if you can't retrieve it, then it wasn't remembered. Doesn't mean it's not there, it just means you can't retrieve it. And the problem with that, it begins to have this cognitive working load. There's a max, right? As engineers, there's maximum and minima in lots of systems. Let me skip that story. So there's maximum and minima, and there's working cognitive demands. The story I will tell you about this is, I've got a 13-year-old, actually he's a 14-year-old. I got a 14-year-old who's in 8th grade. When he was in 5th grade and we lived in Ohio, he was required to memorize the Gettysburg Address. And he did. And he said the whole Gettysburg Address to his teacher, and either got an A, B, C, or D, whatever, depending on how accurate he was. Now he's in 8th grade. Guess what he's doing in 8th grade? Social studies. Well, there's only one answer to this question. He's memorizing the Gettysburg Address. Now, the funny thing is, this is happening while I'm writing these notes, and I'm making notes like, this is perfect. But he doesn't remember the Gettysburg Address. He remembers the experience of memorizing the Gettysburg Address, but he doesn't remember the words to the Gettysburg Address, particularly toward the end where everything kind of got fuzzy, right? Because he was cramming that last stuff in. And that's this working cognitive demand. You start cramming stuff in and it starts getting fuzzy, and it doesn't always stick, and it doesn't stick as long as you want it to stick. Secondarily, some people are better memorizers than others, and that depends on how their brain is structured and how they cognitively store that information, right? So organization becomes a significant part of memory. So one person might feel stupid because they can't remember, another person feels smart because they do remember, but it might not be intelligence exactly. It might just be how their brain is structured to hold that information and how easy they can retrieve it. The other part of memory theory is the notion of tabula rasa, right? This is the Latin for blank slate. And that's the theory that students walk in, particularly young kids, walk in as blank slates, and I can just, espouse my wisdom on them, and they're just going to be wonderful learners, right? That doesn't exist either. Even if you end up teaching little kids, the ones who still leak, right? They walk in with background knowledge. The students you're probably going to work with, undergrads essentially, maybe grad students too, are obviously going to have lots of background experience, lots of context, which goes back to, I want to say your name was Michael.
Yes.
Michael's point of also making personal. Right? So we've covered behaviorism, we've covered memory theory. Third one is constructivism. And constructivism probably is new to you, I'm going to guess. Yes, is it new?
Yeah.
But it's actually been around quite some time, depending on when you start the clock. I think in terms of educational theory, and it's being called something, it's 30 or 40 years old. Hey, good morning, how are you? It's 30, 40 years old. It's probably the dominant theory now in most education. Elementary ed, my background is science ed, is constructivism. And the idea is that ideas, thoughts, and experiences all shape how we understand how the world works. The goal is the brain wants to figure out things so they make sense. It's a sense-making process, right? So there's this assembly and reassembly of information into a mental structure. So teachers sometimes talk about scaffolding learning experiences. And you have to tell me your first name again.
Candy.
Candy.
D.
Candy.
Candy.
So I still said it wrong? You're just being polite, huh? Well, thank you, I appreciate that. All right, so the mental structure is maybe someone needs 2 steps to get to the figuring out the number of pounds of CO2, while someone else only needs 1 step, right? Then that's this notion of scaffolding. How many steps are needed to get the learner from where they are now to where they want to be? My favorite, like, default phrase that keeps me remembering what constructivism is this notion, this 9-word sentence I found in an old article, and that is that knowledge is created in the mind of the learner. So you can tell me on Wikipedia there's information, but that doesn't make it knowledge. It's the knowledge that you created up here and stuck, it made sense to you that you were able to, that we count as knowledge, it counts as learning. Right? But again, going back to this age thing, how old is constructivism? Piaget, the social psychologist, did you all have to do Piaget in your humanities background?
Not in my background.
No? Okay.
Maybe leadership
Anyone else?
studies.
Piaget? No? So Piaget is a neat guy, Swiss, I think, but it's a French-sounding name. He's really interested in working with little kids, and he would do stuff like, my favorite one is, he took a square cube, and imagine the cube is 10 centimeters, 10 centimeters by 10 centimeters, right? So it's actually liter size, but cube, it's cubic. And then he has a long, tall 1,000 milliliter or 1 liter graduated cylinder. And so they look completely different because one's really tall, one's really short. And he pours the 1,000 into the 1,000 and they're the same. But some kids didn't see them as the same. Only after they reach a different stage of maturity could they recognize conceptually 1,000 milliliters in a tube is the same as 1,000 milliliters in a cube. So he talks about stages of learning. He also talked about accommodating knowledge and having disequilibrium. And that's the idea, like, doesn't make sense. It's still, something's wrong with this picture. And struggling, right? Assembling and reassembling ideas. And that's Piagetian thought, or Piagetian theory in a nutshell. Vygotsky's in this turn of the last century, Russian, whose work doesn't get to the West for 100 years because of the Cold War and communism. But he talks about there's this zone of proximal knowledge. So if you think of the zone of proximal knowledge as a window, you shoot too low and it's too easy for them and they're not challenged. If it's too high, then it's way above their head and they're not going to understand what's going on. And so Vygotsky talks about the ZPD, the zone of proximal development. There's a window that's appropriate for your learners. And that's, again, where you decide, if I give them the CO2 in gasoline question, do they need 3 steps, 2 steps, 1 step? Depends on their zone of proximal development. I would just add that the famous phrase in education called the guide on the side versus the sage on the stage. Right? Today I'm acting like the sage on the stage. I have some information, I'm spreading it out to you literally or figuratively. I'm opening up your skull cap, I'm pouring knowledge into your brain, and I'm hoping you get it back. Right? Educationally speaking, we're moving away from that model, and we're trying to be over here, where there's something else going on, and I'm the sage, I'm the guy on the side as you go through this process, as you personally assemble this knowledge and or reassemble this knowledge. That's constructivism in a nutshell. So take a deep breath. Really. All right. So what are your impressions? Behaviorism, memory, constructivism? What are your impressions of those 3 theories of learning?
I think different domains might use different approaches or different theories. For example, like engineering might probably use maybe the constructivist one, and then some other disciplines where it's maybe like writing intensive, you have to read a lot of books and form your own knowledge of all of the things that you have read so that you can put it together, because your exams are mostly going to be essays and things like that. So you probably use a different one.
Okay. Thank you. Other people?
Well, I think any individual may have to use it depending on the location they are teaching in or what they're trying to learn. But like constructivism theory resonated with me when we had to study Creswell in leadership studies. And
And he's the assessment educational research guy, right?
yes.
Yeah.
And so it was several more theories, but I remember constructivism because that's what was related to my dissertation topic.
Any other impressions of these?
I think we move from one stage to another, right? They create the syllabus for each courses based on the behavior. Then they teach based on their memory. And some courses we need the constructive. I think we go through all these things.
She's dead nodding. And I would argue that, yeah, and if I speak broadly about engineering, which seems to be the tie that ties this group together, particularly lab type work, lab safety, lab mannerisms, right? That's behaviorism. You always have your safety goggles on first. You do X before you do Y. And there's behaviorism in there. Memory theory, as a chemist, there's this thing called pKa's, right? This is how easily a proton would fall off of another molecule. And people would just expect you to know these things and well, what's the pKa of ammonia? And you vomit that answer up, and there's nothing to do but memorize. And there's some things you just have to memorize. Columbus supposedly landed in America when? Oh,
1492.
There he goes. All right, that's a memorization thing, right? But somehow it still seems to be a useful, trivial fact. And I would add that perhaps that's one of the warnings about this is that you just have people memorize trivial things, and whereas constructivism is, I think, more interactive, more engaging. I think you talk about the how approach, and it's visualizing things, but it's sense making. All right, so I want to also chat a little bit about lecturing, because if you become a college faculty member, chances are really high you're going to lecture. I don't know what the probabilities are. I'm not very good at statistics. I think it's going to be like 105%. Now, I want to make a side commercial too. Do you mind? I Googled a clip art for lecturing. And I wanted just a cartoonish clip art, something simple on lecturing. Never found one with an African American on it. It was only white people, white women, mostly white men lecturing. So the fact that you're in a program called Preparing Future Minority Faculty, this really isn't from the lecturing search that I did. This really looks like an elementary teacher, doesn't it? It was really hard to find somebody that was culturally relevant in this. And that's my commercial. So persist. Oh no!
Just
I was here.
that's fine.
All right. So another poll, another intimate, just off the top of your head. Your dream lecture. What does it look like? And I don't mean like, oh yeah, I've got the plaid jacket on with the elbow patches. Anyone see a lecturing guy like that with the pipe and maybe one hand in the pocket, like they pontificate, right? I don't mean that ideal. Like what ideally happens when you lecture?
And you mean from the perspective of the instructor?
From
Right.
as your future, like I said, there's like 105% chance you're going to lecture.
You're providing information to the students, like a background of the subject matter.
All right. So background provider, you're providing knowledge, you're providing information. Thank you. More.
We have students with different degrees of knowledge and understanding of the topic that you're teaching. And then we also have students who want to learn, who are open and willing to learn, and then we have some that play on their phone and try to try.
Are unmotivated, sure. And I think that's very honest, right? There's going to be people come in with different background knowledge. How do you get them onto the same page? There's gonna be some who are motivated to learn, and there's gonna be some who probably are hungover and have no joy in being in a classroom and will either, so we didn't have cell phones when I was in graduate school, so we just had, we did the crossword puzzle as a way of, being in a lecture, without really being there physically. I'm sorry, I said that wrong. Physically we're there, mentally we were somewhere else, which I think is what you're saying, right? So, there's problems with lecturing. Lecturing is actually problematic. And, it's a remnant of an older system that's really being critiqued in modern universities and has been for probably 20 years. The critiquing started, and lots of universities are looking for other ways to deliver information rather than like this mode, right? So here's some of the problems with it. I'm not from the South, but I'm gonna go for it. Ready? Y'all are passive right now. Is that correct? Actually, you could actually be hungover, and I wouldn't know it, except for the fact that you probably washed your face and maybe put some eye drops in. Your brain doesn't necessarily have to be here. You could be in like ravaging pain, and if you just smiled and nodded every once in a while, I'm like, yeah, I'm a good lecturer. I really nailed this. To your point, right? We should be able to use the B word. Lectures can be boring. Boring is snot.
Yes.
And as I said, it's derived from the medieval universities. And I'm trying to make this one more engaging, man. There's only one prop for my whole hour here. All right. So things you can do to enhance your lecture. One is plan. Okay. Well, so this is awesome. My instructor, my advisor in grad school, was a pretty sharp guy. He actually was going to be a lawyer. Got into chemistry as a undergrad, decided he wanted to be a chemist then he decided he wanted to do physical chemistry. And if you know anything about physical chemistry is mostly math. It's a lie, right? They really don't even look at chemistry, the chemicals. They just do math all day and write programs. And then he did that, and then he started, and he's one of the originators of chemical education. So he kept reinventing himself. And when he lectured in physical chemistry, I sat in one of his lectures one day, he'd take a 3x5 card out of his pocket. He'd look at it, throw it in the trash, and then he would write. Look at the next card, throw it in the trash, and then he would write. So I don't think he really planned. And I don't advocate your lecture on a 3x5 card. But I do advocate, think about where you want to be at the end and work backwards. Right? That's beginning with the end in mind. What's the target? And then work backwards. And this will also go into those. Then, after you've got that, then have an introduction. Anticipatory means those things. Can we start with a question that will get people thinking for that entire lecture? Can you umbrella the lecture with one question? By the end of the lecture, we should be able to answer this question, right? How many pounds of CO2 are there in a gallon of gasoline? Maybe we can. Maybe that's too simple of a question for your group. Maybe it's just the right amount. Try to make it engaging. Maybe I'll get invited back and we can go over how to make it engaging. But at least for today, for our superficial pass over this idea, your introduction should be engaging, thought-provoking, or something. Maybe there's a video you need to show. I don't know. Then you do your main body, which is your expertise. I can't help you with that. But also, think about how the lecture ends. Many of my lectures ended by, it's 12:30. See you next Tuesday, right? It shouldn't work that way. There should be some sort of wrap-up. There should be some way that you can check you made the point. Does that help? So if there's one slide, even a half a slide, right? This is what I would recommend in terms of what you asked me to do, Dr. David. Right. So a little bit of advice on lecturing. First, set objectives. If you haven't had to deal with objectives, they're not much different than your research problem you did for your PhD or you're doing now for your PhD. Somewhere there's an active verb in there that says, I'm going to invent this. I'm going to understand this thing better. I don't know your disciplines well enough to give you a really concrete example, but that's it, right? But the idea of an objective when you lecture is it should be observable and it should be measurable. So that means you have to find a verb, and it's really verb-based. That's the key, is finding that verb by the time you're done. Right? So define's really low level. Just before this, I was at a elementary school. We were working on heredity, and I wanted my 5th graders to be able to define the term trait, inherited trait, and acquired trait. Right? Pretty low level, but they were able to define that. Compares a little bit higher level. There's 2 theories, right? We should be able to compare theories. Analyze. Now we got some data. What does this data mean? You have a graph. It's got a slope. What's the area under the curve? What's the line of best fit? Those kind of things. You know, the PhD really is this, right? You have to solve some sort of problem or justify. Going back to the humanities, right? And I think someone mentioned reading, right? You have to read, and usually there's some sort of thesis statement, and then you have to justify why this is true. And that's really hard to do. That's higher level thinking. But my point is finding those verbs for whatever you think is important in that lecture. Secondly, it's got to be student focused. What I found when I was high school teaching and I was working with undergraduate students who wanted to be teachers is they say things like, today, it's Monday, it's the 25th, I'm going to introduce the students to the topic of combustion. And I would ask them, what do you mean you're going to introduce them to combustion? Do you say, hey, combustion, I want you to meet so-and-so, combustion, and you've been introduced. That doesn't really make sense, does it? You can't introduce people to a concept, right? That's not student-centered. That's you focus-centered. And I'm trying to figure out how to say this politely. You have to put your ego aside, right? It can't be about you. Even though you're the primary provider of information, again, going back to the side, right? It's about the student. So it has to be student-focused. So I would, if you think the suggestion, put in the students will be able to format, right? You can't say the students will be able to introduce. It doesn't make sense anymore. But the students will be able to define combustion. The students will be able to solve a problem with combustion. The students will be able to justify why burning paraffin is better than burning gasoline or something like that, right? Now it's student-centered, now it's student-focused, and you're going to be more effective. Does that make sense? Is that helpful? Okay. There's 3 no-no terms up there also. And the no-no terms are really easy to fall into traps, right? Well, today's lecture is going to be about combustion. By the end, the students should understand combustion. That sounds good, right? The students will learn, or the students are going to know. And those are good, but those are probably overarching goals, but they're not specific objectives, because you can't, in the time you have a lecture, even if it's a 3-hour lecture or a 1-hour lecture, you're not going to be able to measure knowledge. You're not going to be able to measure understanding. You're not going to be able to measure learning. If you keep it something specific that's measurable and or observable, then you can know if you were a success. Does that make sense? This is yes. We're doing our calisthenics now. This is yes.
Yes.
You can also do this. This is no. All right. I said that right. Any questions before we move on? All right. So I have a couple examples here. Today, I'd like you to be able to compare and contrast the different theories. Theory of memory, theory of behaviorism, theory of constructivism. Have we done that? All right. Today's lecture also set out, I'd like you to describe an ideal structure of a lecture. And lastly, I'd like you to list rationale for implementing an assessment technique. To me, this is what I said in my mind after I received the email. Realized I couldn't do what Dr. Bigsby wanted, but if I could do something that smelled like it, he'd probably at least be satisfied that it was okay. All right. So we need a rationale for this, and we need to figure out how learning takes place. So this is where we get into the weeds. This is the nuts and bolts of it, and this is probably where it potentially gets the most boring. But I couldn't figure out a way to make this more engaging and interactive. But there's 6 of these squares. 3 are on this slide, 3 are on the next slide, and they're taken out of a manuscript written by a group of deans of the College of Education have gotten together, and they've created a consortium called Deans for Impact. And they put this document out, so they want other colleges of education to do this, as well as deans from other departments to impress. So I'm not going to elaborate on them too much, but I'll put them up there now. So this goes back to making connections, right? First one is students learn new ideas by relating them to what they already know and then transforming them into long-term memory. So they have to connect to something familiar is really what box number 1 says. Number 2, students remember information better when they are given many opportunities to practice retrieving it from their long-term memories and thinking about its meaning. So you can see there's memory theory in there because it's retrieval, but you can also think about sense making in that last phrase and thinking about its meaning. But the point of this box is it's iterative. And it's really nice if it's not only iterative, but the iterations come from different perspectives. Tell them the answer once about how to get that answer. Have you model solving it. Have them solve it. Now, take them to a lab if you can do it in a safe way and blow up some gasoline. You know, if they have multiple experiences doing that, then they will remember. I forgot one of you said you're electrical engineering. So here's a funny story. I hope the rest of you enjoy it. But you might get a kick out of this most. I work with teachers who are going to teach elementary students. Most of them are science phobic, don't like science at all, or they had a bad experience. They're not stupid, by the way. Very smart people. They just happen to either dislike science or had a bad experience that killed them from wanting to learn science later. But I want them to learn a certain way of doing a teaching approach. So I give them a battery, a bulb, and a wire. That's all. And I say, make the light bulb light up. I thought you might enjoy it. It's really hard. They all have different ideas on how it should light up. But the neat thing about it is it's self-accommodating. Once they get to light up, they got it. I don't have to tell them the answer. The bulb goes on, they know they have the right answer. And it's not trivial, actually, because they have to think about circuits. And even though they've been around electronics all their life, the concept of a simple circuit has never been really formally taught to them. And so it's pretty amazing. But once they do that, then I give them other opportunities. I give them 2 batteries. Now they do a series circuit, because that's kind of default and easy. They can, the activity before that, they play with a flashlight, so the batteries are in series, right?
Right.
But then I make them think about, there's a different way to hook the batteries up. And it's bizarre, and it's, you have to think out of the box, and it's very difficult, and I tell them that, and they eventually come up with parallel, which is really hard. I don't know if you've ever had someone derive parallel out of the blue, but it's very difficult to think in terms of parallel just after you've had done series. But my point for that story is they're going to remember that day because they iterated. They did this activity a couple different ways, a couple different times, and their understanding is better. All right. Lastly on this slide, so problem solving, critical thinking skills are developed by feedback and depend heavily on background knowledge. So it goes again back to, I think what Michael said, knowing your students, knowing your learners, and then I think also what you mentioned about giving them feedback, providing them your coaching, right? You basically got to provide feedback for them. So the second slide, I think I'm running out of time. Am I done at 30? All right, well, I'm going to be trying. I'm shooting for you to be done at 30 because I know you all have different things to do. Transfer is a big idea too. Particularly if you've been a high school teacher. The number one criticism of people who teach seniors and juniors in high school at September is what? Anyone got a guess? They forgot everything over the summer, right? Yeah. Or if you've taught like something like Intro to Chem 1 and now they have to do Intro to Chem 2, or even worse, they did the whole year of chemistry and sophomore they do organic chemistry. And somehow magically in that summer between the end of Chem 2 and the start of organic chemistry, they forgot everything. No, they don't. They just, the transfer is not simple. It's a little bit more sophisticated. They need to make sure there was some deep, I'm such a touchy guy. All right. They have deep understanding before they can get to the next and make that transfer happen. Motivation then is a huge area, and motivation has multiple facets, way more than we can talk about today. But the fact that some want to be there and some don't want to be there is significant. It's a key point. And lastly, misconceptions about learning. You have to invest yourself in a little bit about how we understand learning works. There's lots of misconceptions about learning. The one I thought I would model is in biology. When I was an undergrad, there was this idea in biology that said that ontogeny recapitulates phylogeny. You got that? No. Ontogeny recapitulates phylogeny. You got that?
Not yet.
Ontogeny recapitulates phylogeny. So what misconception am I modeling? I'll tell you. He didn't get it, so I raised my voice. He didn't get it again, so I raised my voice even louder. Do you think learning really occurred because I raised my voice?
No.
No.
Look around next time you're watching someone trying to learn. See if the other person doesn't raise their voice, thinking, if I yell at them, learning will occur. There's a misconception for you. It doesn't work that way, right? Yes, sir.
Dr. Ferguson, have you ever used an example from the periodic table when you're trying to get students to learn?
I was a high school chemistry teacher, so yes, but I'm not sure where you're going with the question.
Well,
Is
I'm
there a
saying,
question behind the question?
yeah, like you're trying to get the kids to learn or the students to learn how many halogens come from a certain table of the periodic table. I'm just thinking that would you ever use an example like that?
I did. I used to teach chemistry, and when my understanding of it was I would make them memorize it. There was just no way to get around it. But while they had to memorize it, we did activities. Matter of fact, it was an activity. It was a paper activity, for lack of a better word. Like, it wasn't hands-on things to touch.
Okay.
But they got data, and they looked at periodicity. So they looked at increasing electronegativity, and they saw electronegativity go down the graph, and it happened to correspond with going across the periodic table, right? So if you went across the first row, you had a certain amount of electronegativity, actually, that way. And then electronegativity would go up again around sodium, and then it would go back down as you got over to neon. And then it would go back up again, and it would go back down as you got over to xenon.
Okay. Okay.
So there was graphs that went along with periodicity.
Okay.
Then we did other things that if anything, going back to the previous slide, they iterated. They had multiple perspectives. They saw multiple facets of it.
Okay, cool.
That help? And probably in your own disciplines, there's things like that. As I said, going back to the theories, behaviorism isn't a good theory if it's your only theory you operate from. Behaviorism, I'm sorry, that was memory theory. Memory theory, like memorizing the periodic table, or I know in electrical engineering there's little color-coded things that tell you resistance on resistors. There's little color codes, and you have to read those codes, and you tell you the resistance. Right, so you have to memorize those things. There's some things that are inescapable memorization.
Okay.
In undergrad, I took Japanese. Guess what? I had to memorize the Japanese
I
letters.
took Japanese.
What's that?
I took Japanese in undergrad.
Did you?
Yeah.
You had to memorize, so you had to memorize the hiragana and katakana, right?
Hiragana and katakana.
And there was no other way around it. There's just nothing you could do about it. You just sat there and practiced them over and over and over and over and over again, right?
Yeah. And I watched anime online so I could understand the language in class.
What's that?
I watched anime online.
Oh, did you?
Yeah.
Oh, cool. Did that help?
Yep.
And see, multiple perspectives. There you go.
Yep.
Multiple iterations. I think that's everything I want to say on this one. So assessment. All right, we'll wrap it up with this. Assessment. Assessment means this. It comes back from the old Greeks, like Socrates and those guys, when they would have tutors, and the tutor would sit next to, usually the human model, and they would sit beside the person, and they would tutor with the person who needed to learn, and they would appraise their learning. Right? So that, if you think of assessment, its roots come from appraisal. So if you have an old, valuable antique, you get it appraised. It tells you its worth. Right? So that's the idea of assessment. There's two reasons I'd like you to leave you with in your mind of why you assess. The first one's obvious. Did the learners learn? Right? This is delta. If they walked in knowing something and they walked out knowing more, then you have a positive delta. This is a good thing. This is why colleges will pay you to lecture, because they walk out knowing more than they walked in. But you should also use it, not to touch, to inform your teaching practices. If you take time and look at how performance is, it should inform you about how well you're doing. And that really means you have to be brave enough to admit that you can improve. Because in my hallways, even in the College of Education, the number one thing is how's your students doing? Oh, they don't read. Really? I mean, that sounds like blame the victim, right? Maybe there's something else going on and you're not willing to look at your own practice. But if you're willing to look at your own practice instead of just blaming the students, you probably will grow as a professional as well. When to assess, this is the one joke that I've had in here that I thought might be funny. You only assess 3 times in your lectures, before, during, and after. Right? There's technical words for these. Anyone got to guess what the before assessment's called? They call it pretest, right? These aren't hard words, right? In the middle, it's called formative. At the end, it's called summative. So those are the 3 times you assess. I like before, during, and after. So I had to make them more Greek, right? All right. I think I did that right. All right. So when to assess, you can do all these things. You can assess formally and you can assess informally. I like to think of assessment as litmus paper. If you going back to chemistry, if you've done the litmus paper thing, there's blue litmus paper that turns red, and there's red litmus paper that turns blue, right? And it doesn't take much, but it gives you information. In this case, it's acids or bases. But in your case, it might be, are they getting it, and how am I doing? And there's a couple ways. If you want to test in the middle and you want to keep it informal, there's polling apps now. Lots and lots of polling apps, and you can, and some of you are already using this, right? So you're already doing informal, formative assessment. You're assessing along the way. Something more formal might be, okay, at the end of the section, in the middle of the chapter, I'm going to give you a chapter quiz. Summative then means maybe that in-class big question that you had at the beginning of your lecture, you set up so there's a no penalty, it's easy to do, or not easy to do, but it's informative to you, and you give them some sort of question that they have to answer, and that could be an informal way to have them summarize and get that information. And then, of course, everybody knows formal summative is the end of the chapter. I could probably fill 7 or 8 more slides on this, but I'll leave you 2 more ideas. One, we tend to assess on the way we learn best, or we assess best. So if you like pictures, I like pictures. I'm very graphically oriented. I understand things if I can draw out a picture after someone explains it to me. So my tests tend to resemble that. You want to be aware of your own biases as you test. That makes sense?
Yeah.
So otherwise you're just going to get learners who learn like you, and you're going to say, what a great instructor I am. But if you're really a great instructor, you're going to get the learners who don't learn like you to learn, and then you've accomplished something. Secondly, ensure that you're offering multiple routes. It's the goal should be they demonstrate their knowledge, right? And so you go back and you have them show you how they get it. And then you can be a little creative on how to get this, right? Here, there's 4 different ways to demonstrate knowledge of your learners. Again, I think a selling point that I would like to leave you with is if you do this thing with objectives, they drive your assessment. A real good set of objectives at the beginning makes writing your tests much easier because you've set out what you think the learner should know by the end of the unit. There's a little bit of advice. I think that's it. Align your objectives with your assessment. That's the logical thing to do, but it's amazing how people get to the end of their unit, all of a sudden they write up a test and they don't know whether they did it or not. Maybe this has happened to you, is all of a sudden magically a test question shows up on something you didn't teach. Maybe this happened to you as a learner. When did the instructor go over that? I don't think we did, right? And all of a sudden this magical question shows up. Be very cognizant of that. The goal is going back to the objectives, not how smart you are or how you know how to trick students, but the goal is for them to demonstrate their knowledge by having a well-aligned assessment with the original objectives. And then lastly, maybe this is more of a high school thing, but don't make it a punishment. And I think I'm almost done. Can you hang out 2 more minutes? Me too?
Absolutely.
All right. This is my summary slide. If I had time, there would be arrows interconnecting all these. But the idea is educational theory drives your actions as a lecturer, and constructivism is the idea that you are constructing knowledge or assembling and reassembling knowledge. A lecture then should be objective driven and student focused. And lastly, the assessments you should be aligned with the objectives. and they should improve your practice. And you can see all these interconnect. I just couldn't figure out how to do that using PowerPoint. So if I had the ability, I would draw arrows in between these, and if I hadn't run out of time. So how did I do? Did you get to compare and contrast different theories of learning today?
Yes.
Oh, thank you. Can you describe the ideal structure of a lecture?
Yes.
Can you at least one rationale for implementing an assessment technique?
Mhm.
Give me one.
The test,
All right, why? Why'd you test?
to see what they have learned.
All right, anyone else?
To see how you're doing.
See how I'm doing, all right? I'll leave, this is my last slide. Well, actually, my second last slide. The last slide was my closing thoughts as a colleague and future colleagues. If you can, you're never going to get rewarded for this in your fields, but if you can, try to get involved in the education side of your profession. Right? In my profession, we have the American Chemical Society. It's actually one of the largest professional societies in the world, but it produces the Journal of Chemical Education. The National Science Teachers Association is mostly a K through 12 organization, but they even publish the college teacher, and that's for college professors, right? And then finally, there's also even the Society of College, Society of College Science Teachers even has their own society. By that, I imagine there's parallel professions for you to be involved with as well. And then if you need me, I'm not too far away from the bell tower, and over at Proctor Hall, there's my phone, there's my contact information. And thank you for participating and kind attention. And so if you want copies of the slides, I'll send them to you.
And I'm happy to share them if you're okay with that.
Oh, yeah.
I can share them to everyone in
Okay.
attendance,
Okay.
because I know everyone would like to look over some of those details in a little bit more. Yeah, in their own time.
That's about it. I guess I can answer questions, and if not so, you have to go. Do those research calling, research meetings, whatever else you gotta do.
Sure.
All right, thank you again.
Thank you very much. Thank you for reminding me.